Hello everyone. In this lecture we are going to see about graph data structure, and previously we had seen a basic of graph, okay, and few things, properties of tree also. So here we will try to understand why we need a graph when we already have a powerful data structure like tree, right? Now before understanding that, let's see the difference between tree and graph so that you can understand properly that why we really need a graph. Okay, so the difference is, you can clearly see in terms of structure, tree is a hierarchical structure. Okay, it represents a hierarchical structure, or you can call it is a model, and graph represent a network structure, means it represent a network model. What does it mean? We already seen this. See here, if I draw a tree like this, A and B, then what is the meaning of it? A is a parent of B and B is a child of A, right? So that hierarchical structure is maintained, right? Now if I draw the same thing in graph A and B, then A and B, what is the meaning of this? A is related to B and B is related to A. That means A is a friend of B and B is a friend of A, right? So it represent, this edge represent a relation here, and this here it represent a hierarchy, right? Now it contains, tree contains a root node. That, for example, here A is a root node. This root node is must in tree, it will always be there, but in terms of graph it might not be there. There is no root node. Okay, now in terms of cycle, tree never has a cycle. Tree will never has a cycle. But in terms of graph, when you talk about graph, graph can exist. A graph can have a cycle. For example, if I take this example only, then I can take one more node, that A is related to C and B can also be related to C, right? Now this cycle is possible, right? In graph, cycle is possible. So this is also graph, but this is not a tree. This is a graph, but this is not a tree. Now parent relationship. Every node has exactly one parent. This is the thing. In tree, every node will have exactly one parent. It will never have more than one parent. But coming to graph, it can have more than one parent. Okay, you might be wondering how. Let's take this example only. I will convert into directed graph. Then you can understand. Okay, I had put the direction here. You can see the direction. So after this, you can clearly see one thing, that A is related to B. Okay, observe this B part. Okay, A is related to B and C is also related to B. So you can see that B has two parents, A and C. Okay, if I frame it in a hierarchical structure, you will understand. There is a B here, right? And there is a and C. Okay, now according to this hierarchy, if I put in a hierarchy, then you can clearly see A is related to B and C is related to B, and for B, A and C both are like a parent. So this kind of structure is never possible in tree, but in graph definitely. So that's why they are calling it can have multiple parent, right? Now coming to this point, number of edges. We had already seen that if there is n node, then edges will be definitely n minus 1. Okay, for example, here two nodes are there, then edge is 2 minus 1, which is 1. In tree, this property is going to be hold. It can have any number of edges. This property doesn't hold in graph. Okay, it can have any number of edges. Okay, that is not a restriction. Now coming to connectivity, it is always connected. Tree can never be disconnected. But coming to graph, it can be connected or disconnected. Both is possible. Okay, I will give you one example. For example, to understand this, let's take one more node here, that is D. Okay, and I will try to connect it with B. Right. Now, let's give some direction also. Now this is a graph, right? And this is called connected graph. Every edge is connected to, every node is connected to each other. Okay, every node is connected. Now, what is the meaning of this is, what is the meaning of this line is, it may or may not be connected. What if I remove this edge? Okay. Now, is it a graph now? Now question is, this entire thing is a graph or not? Yes, still this is a graph. This entire thing is a graph. Okay, there is one graph here and this is one another node, right? And this graph is called disconnected graph. This entire thing is a graph, right? And it is called disconnected graph. Okay, so don't get confused. That's why it is written that a graph may or may not be connected, but here it is always connected. It cannot, this kind of structure is not possible in tree, right? Fine. Now the next point is, we had already seen this point that paths between a node, exactly one path exists between any two nodes, or one path or edge, or multiple path may exist between a nodes in a graph. Okay, we had seen this part in a different one of the video, right? So if I'm consider this example, okay, we can clearly see if I want to reach from A to F, there is only one path to reach from A to F. You have to go from A to B, then B to C, then C to F. Okay, no other path exists. Can I go from A to B, then B to F, then from E to F? No, that is not possible. Only one path is possible. But coming to graph, okay, if it is a graph, then what I will do, I will take this particular tree and convert it to graph, and I will connect this. Okay, now it is a graph, right? Now if I ask you, see, there is a multiple path exists. Yes, definitely. If I want to reach from A to F, then from A to B, B to C, and C to F, one path. Or I can reach from A to B, B to E, and E to F. Okay, so in graph this is possible because loop is possible in graph, cycle is possible, but in tree it is not possible, right? So that is the meaning of this particular line. Okay, so after that difference, let's see why we really need a graph. Okay, we have such a powerful data structure like tree, then why we really need a graph? So before that, let's ask one question. Whatever the network model and whatever the real relationship model is there in the real world, can we represent using a tree data structure? And there is it possible? There would be some flow, right, in tree data structure. That is the reason we need a graph, right? Let's see what is the problem in tree data structure when we try to establish a relationship, or we try to develop a network models. Okay, so when you try to create such type of network models or relationship, at that time a tree data structure will not work. Okay, let's take one simple example like Facebook friends, and we can understand it in a better way. For example, let's try to build a network model, for example this relationship model, using a tree data structure. If I'm using a tree data structure, okay, then what I will do, I will take for example, I will take A. Okay, A, who is A? Consider A is Arun. Okay, now Arun is a friend with someone called B. B means, what name should I take? Bhuvan. Okay, so I can represent like this with a tree data structure. Yes, so Arun is a friend of B, of Bhuvan, and Bhuvan is a friend of Arun. Okay, fine, we can represent this. Maybe Arun is also a friend of C. C for Chetan, for example. Fine. Now Arun is now with this data structure, with a tree data structure, what we are represented is Arun is a friend of Bhuvan, and Bhuvan is also a friend of Arun. Arun is a friend of Chetan, and Chetan is also a friend of Arun. But in real world, this is not the scenario always. It may be possible that Bhuvan is also a friend of Chetan, right? Or Chetan is a friend of Bhuvan. Now, if I try to establish this relation using a tree here, okay, then what I have to represent like this, right? To represent the relation. Then what will happen? Then there is a cycle inside the tree data structure. And if there is a cycle inside a tree data structure, then it is not a tree itself. Then it automatically becomes something called graph. right? So you can clearly see, if I want to establish a relation between Bhuvan and Chetan, which is in real world, it is possible. It's not that Bhuvan can't be a friend with Chetan. Maybe the Bhuvan is a friend of Chetan also. And if I try to develop that relationship using a tree data structure, then there would be a cycle. So here where the tree data structure fails. I will take one more example of a road map. Okay, you might be using a Google map, right? So Google map using a road map uses a road maps, okay, to reach from source to destination. So like let's try to build a road map, okay, of one from one city to another city, and let's observe how tree data structure will fails even into even to develop a road map also. Okay. Okay, now for example, I'm trying to, I had designed a roadmap using a tree data structure, and this is my roadmap. Okay, so using a tree data structure, I developed this node map. Now, suppose I want to go from Delhi to Chennai. Okay, so what is the way to go? The route is I have to go from Delhi to Mumbai, and from Mumbai to Goa, and from Goa to Chennai. And this is one way to go from Delhi to Chennai. Is there any other path or any other route to go from Delhi to Chennai? Let's observe. If I start my journey from Delhi to Bangalore and from Bangalore to Cochin, okay, you can't reach to Chennai. If I start from Delhi to Mumbai, then Mumbai to Pune, no, not possible. Then what is the reason? Now you can clearly see there is only one pathway to reach to Chennai. But in real world, if you observe that uh, we have multiple paths to reach from one source to destination, right? If I want to reach from Delhi to Chennai, I- if I start my journey from Bangalore to Cochin, from Delhi to Bangalore, then Bangalore to Cochin, then is it not possible from Cochin to Chennai I can reach to Chennai? From Cochin to Chennai, can I reach? Yeah, in real world it may be possible. Or if I start from Delhi to Mumbai or Mumbai to Pune, is it not possible for Pune to Chennai? There would be some path. Yeah, definitely there would be some path. In real world it is possible, right? But if I try to represent that thing, for example, if I try to represent from Cochin to Chennai, one more path here, okay, or Pune to Chennai, one more path here, right? Then what will happen? You can clearly see there would be some cycle here. Okay, that is one thing. There is a one cycle here. Then definitely this is not a tree data structure. And one more thing, there is a one more definition of tree, that there should not be, see, there should not be multiple paths. There should be only one path exist. Are we now? You can see if you are representing a tree data structure, then there should be only one path. But here to reach from Delhi to Chennai, we have multiple paths. Now we can go from Delhi to Mumbai, Mumbai to Pune, and Pune to Chennai. Then from Bangalore to Cochin, then Cochin to Chennai. Multiple paths are there. So you can see there is a cycle now, right? And there is a multiple path. Okay, and this both property should not be there in tree. But if you want to represent real life data, real world data or real world roadmap, then you have to take this data into consideration, which is not possible with tree data structure. Are you getting it? That is why the tree data structure fails here also, here also. So that's why we need a one more data structure, that is graph. Right, so this is why graph is so much popular and it is widely used in all the real world examples. Maybe a Uber, Ola, Facebook, Instagram, you name it. Most of the flight route, everywhere tree data graph data structure is used. Okay, so it's very important and hope you understood.